So when they have the phrase to find x in terms of a, they want you to solve for x, and a will be part of your answer. Okay, does that help understand things a little bit better? So sometimes it's an interpretation thing. Okay, so they have a, this is on page 48. In your P2, they have a to the x equals 10 raised to the 2x plus 1. Now, how am I going to start solving this? What's the easiest way to solve this? Drop a log in front. So, I'm going to do x log a equals, now I have a binomial here that I'm moving to the front, so I'm going to put that in parentheses. Everybody's following me up so far? So one thing I know that helps me to simplify here is what? Log, oh, that should be log A. I'm sorry. That's a log A. And what y'all say about log 10?
Oh,
That becomes a 1. So then that means I've got x log A equals 2x plus 1. Now, this is the part that's challenging, and I hope once I demonstrate to you, we're going to see this several times in this particular section of the lesson. You're going to have to get all your x terms to one side. Now, they're not pretty, and they're not going to be able to be combined. So you want to get all x terms to one side. So conversely, you're going to get all non-x terms to the other side. Now, here's where it's confusing. Tell me what an x term is. Just name one of them up here. 2x, that's obvious. X log A. Not just x, but here's where the confusing part comes in. It's x log A. The whole thing is an x term. Unless it's separated by a plus or minus, it's stuck together. So that means that I'm going to move one or the other. So I'm just going to make life a little easier on me, and I'm going to move the 2x. Now again, this is going to be a pattern you're going to see for at least 2, maybe 3 more times in these problems that I'm about to work. So you have a binomial over here. That means what? What does binomial mean? 2 terms. When you have 2 terms that cannot be neatly combined, then you've got to do something because you've got to solve for x. But I can't combine them. It's not like 3x plus 2x gives me 5x. Can't combine those. So what's my other option? Huh? I can't. I mean, I could, but that's not going to get me 1x. Factor out the x. You got to factor out the x, and you're going to have to remember that. So we've got an x, which leaves me log A minus 2 equals 1. Now, once I factor out the x, can I easily get x by itself now? That becomes very obvious. And have I solved for x in terms of a? Yes, I've got x on one side and I've got a on the other. All right, so any questions about 2A? It may be that you need to go back over this, like I said, sometime on Sunday. Okay, let's look at 2. Now, I think 2 and 4 were given to y'all as problems that you need to know from your test, but for your test. But I also put any homework, any classwork, homework, anything like that. So you just got to pay attention. So what am I going to do on this one? All right, let's put a log in there. So they're wanting me to solve and give your answer to three significant figures. So what am I solving for? X. Okay. I don't really care how you approach this. The nasty thing about this one is that you've got log 3 and log 4. Now, you can go on and get a value for log 3, you can get a value for log 4, as long as you use the whole thing in your calculator. So here's what I'm going to do. And there are multiple approaches. I'm going to distribute. So I'm going to get 2 log 4 minus x log 4. Now, what did I just tell you about the last problem? We're solving for x, so that means I need to get all x terms together and then all non-x terms together. So tell me an x term. All right, 2x log 3. Good. Give me another x term. Okay. So I've got to get those together. So I'm just going to move this one over. It doesn't matter which side I move it to. Oh, not what did I do there? Pressing the wrong button. Plus x log 4 equals my non-x term, 2 log 4. Now, I told you you'd see it multiple times. I have a binomial on the left. I have an x term and an x term, and I cannot combine those. So what should I do? Factor out an x. That leaves me 2 log 3 plus log 4 equals 2 log 4. Now to get x by itself, divide by, so take your calculators out. And you're going to put the right side in. And tell me what you get to three significant figures. Everybody get that? Looking back at this, I just want to expand a little bit. Looking at this answer, what if they wanted that with logs in it? How would I rewrite that with logs in it instead of this? I don't want a decimal. I want it with logs in my answer. What would I do? Log. Log 4 squared, which is 16 over, let's write this one as a single, plus, or, y'all gotta speak up because I'm deaf. Turned on today. plus log 4? Okay, how else could I further simplify that? Log. Okay, you got to think about it. You got to think about it. So anytime it's got a plus between it, they might ask you to write it as a single log. You got to know what to do. Okay, that's just a little happy. Okay, so let's look at number 4. Number 4 was also on your test review. Now, number 4 is very tricky. But if you'll pay attention, I'll teach you how to do it. Write that down. Looking at this problem, what is the one thing that bugs you? The what? The right side, absolutely. So, what bugs you the most about the right side? I'm going to get it out of you. Not x over 10, no, but you're 1 over 10x. Okay, so guys, you have to remember that I've told you in this class, we don't have to have just done something for them to make it part of a problem. You should know that negative exponents flip the base. Okay, even though that's not something that we had yesterday, it's not something we had this week, it's not something we had last week, that's something you should know. So can I change this, because I don't like that 10 to the negative x, to 2 over 10 to the x. That's the same thing as 2 times 1 over 10 to the x, just in case anybody's wondering. Follow me? This is going to be on the recording, so please go back over it. So now, what can I do? What have we been doing? Put the logs in front of both. Drop a log in front of both. This is a binomial exponent, so I'm going to put in parentheses, and they've been real nice to me to give me a log 10. Now, I'm going to write this. So, what do you notice as soon as I write the right side? You've got to be able to think. You can expand it. You can expand this. What property is this? Power, product, quotient. It's quotient. How do I know? It is dividing. So, also, I can get rid of that 10. It changes to a 1. 1 times 2 minus 2x is 2 minus 2x. So, this becomes log, how can I expand it? 2 minus x log 10. You have got to be able to recognize when you expand and need to expand, or when you need to write it as a single. Now, do I have x terms and do I have non-x terms? Okay. Tell me my x terms. Okay. Negative 2x. Gotcha. Oh, and by the way, what else can I do to this? Gotcha. Drop the log 10. So I'm going to add that over here. I'm sorry, that should have been a minus 2x. And then I'm going to subtract that 2 over there. Did I get my x terms together, and did I get my non-x terms together? So what is x minus 2x? Negative x. Can I combine those? I can't write them as a single log. How am I going to get x by itself? Divide by -1. So x is equal to -log 2 plus 2. Or 2 minus log 2. It doesn't matter. Okay, that's a lot to take in. So let's go back up and let's talk about, whoops, didn't mean to do that. Let's talk about any part of this problem. I hope once you see it, you're starting to see the things that I'm looking for. But what questions would you have? Now, could you check that? Yeah. Store -log 2 plus 2 is x. And then go back and put in the right side and then put in the left side and see. All right, any questions? So now that you've seen it, do you think you could replicate? Practice if not. Okay, you need to practice it. All right, then the next one we have is number 5. Number 5 says, given the simultaneous equation, show that, we all know what show that means, that's going to be our answer. Show that x is, okay, 1 minute. All right, 10, 9, 8, 7, 6, 5, 4, 3, 2. All right, let's put them up. Uh-oh, that wasn't funny. Okay, so guys, this isn't a normal set of a system of equations. What we're used to seeing would look something like this: 2x plus 3y equals 7, and x minus 2y equals 10. That's what we're used to seeing. But nevertheless, so we can't work it as an elimination, but we can work it as a substitution. So, which one of these two would I start with? Because we're going to this.
Can't work it as elimination, is that what you said?
Mm-mm. But you could work it as substitution.
Okay, I tried to work it as elimination, and I think I got some.
Okay, tell me how you worked it.
I put the log in front of the 2 and 3.
Okay, and you did x log 2
Yeah.
equals y log 3.
And then x log 2 minus y log 3 equals 0.
Okay,
And then you've got plus y in the second equation, so I multiplied the whole second equation by log 3.
okay. So you got x log 3 plus y log 3, okay, equals log 3,
And then I just got canceled the y's.
okay,
And got x times log 3 plus log 2, or log 2 plus log 3 equals
actually, you did do a system, but you didn't do it directly like this. That's what I'm saying. It wasn't set up straightforward. You had to do this first. And then, so yeah, your elimination method was fine. It's just not a straightforward elimination method. Is kind of what I meant. So no, that is fine. And if you work this out, now, okay, how am I going to go from here to here? Because that's what you got to get to. So I get you on this. Whew, I keep doing that. So I'm trying to go up. So you've got to get it to log 3 over log 6. I have the log 3. You got that much of it.
Yeah, okay.
That is, once again, it's that going back and forth between expanding and single expanding. So you have one log here. If you're looking at it and really looking at it, and poor Preston Snyder, he was in the class that I taught the very first time, and he was like, Miss Knight, is it really that ticky? Is it really that detailed? And I'm like, yes. And I've told every class, last year's class I told that, this year's class, just keep remembering him saying, is it really that ticky and detailed? Look, you have one log up here. You got one log here. So when you see that, you need to think single log. So to write log 2 plus log 3 as a single log, they're expanded with a plus, which means you would multiply those. Now, she did it that way, which was perfectly okay. I'm going to show you a different way. Okay? So let's look back up here. Yes, I dropped the log in front of both. I did substitution. Okay, let me show you substitution. So if I want to get x, do I want to substitute x for y? No, I want x in my final answer. So that means I need to get y equals. Okay, so if I'm going to get y by itself, what am I going to do? Divide by log 3. So do I have a value for y now? Okay, so I can put x, we have x plus y equals 1, correct? What is my y? Equals, how do you always and forever get rid of a denominator, and you better get rid of it? Multiply. So if I multiply, that becomes x log 3 plus x log 2 equals log 3. Look familiar? Then I do the same thing that she did. I just arrived at this point a little differently. What can I do over here? I got 2 terms. Factor out an x. Then I can divide by the log 3 plus log 2, and I come up with the same thing. Write them as a single. It's log 6. Okay, that was a lot to take in. Any questions? I know mine's are going, but anything that you want to ask me? Okay, so the last one is really easy. Y'all are going to appreciate number 11. You're like, hallelujah. All right, it says express log 2 x plus 2 minus log 2 x as a single log. How would I write it as a single log?
log 2 x plus 2 over x.
You're dividing here, you're subtracting here, so that means quotient. So that is the single log. You cannot cancel those x's out.
No, the logs. Oh wait, you have to keep the logs.
Yes, you have to keep the log. One log. Write it as a single log, single meaning one. Now, this is another thing Cambridge loves to do. Hence solve. You will see a lot of hence solves. This equals 3. So what do? Yeah.
Okay.
Well, what am I going to take?
Use your single log.
Use your single log, set it equal to 3. Now, how am I going to solve that?
2 cubed
2
equals
to the third equals,
x plus 2 over x.
change it from log form to exponential form. 2 to the third equals that. So that is 8 equals x plus 2 over x. I got a denominator. Let's get rid of it. Multiply. So 8x equals x plus 2. Subtract that x. Divide by 7. And you could store and check that if you wanted to. Okay, guys, so here's the deal. Go back. This is what's going to be on your test. Get up here if I can see this. I should have expanded this out. All right, all of this is going to be on your test. What I would do is you have got 25 minutes. So I would begin studying some of this stuff right here. Go back over them. Make sure you go over quizzes, go over any classwork, homework. You have one review problem from the last test. Okay, so you might want to look over those notes. So this is time that you can ask me questions, because on Monday, I'm not going to work one of each. I'm not going to go through and work all these, but if you've got questions, you need to come to me with specific questions where you've got stuck. All right? So everybody understands? We're going to take advantage of the time.